Alright, what's up? It's the beginning of chapter 12, section 2, screencast. So there's three ways we can solve a problem in calculus. We can do it graphically, looking at the graph, evaluating, finding the y value based on you looking at it. We can do it algebraically, which of course involves our favorite of factoring and having to do on your paper with variables, and then numerically is where you're actually like plugging in. It's like our table of values. So the last lesson explored graphical and numerical methods when we looked at the graph to find the limit and when we used the table of values. So now we're going to find limits algebraically. So first property of limits is the constant value. So another way you could think about this, normally we put f of x right here, limit of f of x. But if we have a constant, it's the same thing as saying y equals a constant, which is a flat line. So if we're wanting the limit, which is the prediction of the y value, it's just going to be that same y value. The y is not changing the whole time. So if we want to evaluate the limit of a constant, it's just going to be that constant. Doesn't matter. If we have a limit of 5, answer's 5. Limit of pi, pi. It's just a constant flat line, so the prediction of the y value is just that flat line value. Now, the difference is the identity function. This is something like y equals x. So as we approach a certain number, that is going to be our limit. So of course, if we want the limit of x as x goes to 30, it's just going to be 30. It's whatever the value is. So notice there's a difference between the limit of a constant and the limit of the identity function. One of them has a variable and the other is a number. Other properties of limits, you can add limits together. You just split it term by term and find the limit of each of the terms. You can do the difference, which is subtraction. So you take each term separately to find the limit, and then you would subtract them all. You can multiply limits. If you multiply by a constant, you pull the constant out front. So you can pause the video, take a look at the examples I've written out, because we are going to be going through each one of these more or less separately. All right, so here we can use the limits of properties to evaluate each limit. Now, normally we don't go over this in such detail. It's a little self-explanatory, but first step we notice is we have a difference. We're having 6 minus x. So let's split it up. We'll take the limit of 6 as x approaches 3 minus the limit of x as x approaches 3. Perfect. This is the first two things we talked about. Limit of a constant, it's literally the constant. Limit of the identity function, it's going to be whatever that x value we're approaching. And then we take 6 minus 3 and we get 3. So really, behind the scenes, we can break a limit down, way down into something like this. All right, so notice we're approaching, we got one side limit, approaching -2 from the negative, from the left side. Here we have an addition and multiplying by a constant. So first thing, split it. So we're adding the two limits. Then, because we have a constant, we can move that constant out front. When we take the limit of the identity function, it's just going to be that exact number. Right, because it's for x, so we plug -2 in for x. So we take 4 times -2 because we have a constant and we're multiplying that constant 4 by the -2, and then limit of a constant is just a constant. So check those out. The next video, this is pretty short because I realized I didn't make one last year. The next video goes through the rest of the lesson.